So our lecture today is on hyperbolas.
Yeah. Love hyperbolas.
What is a hyperbola? So a hyperbola is defined as the set of all points such that the difference of the distances to the foci are equal. So once again, just like an ellipse, a hyperbola is defined by 2 points known as foci. And the criteria for a point to be on a hyperbola is that the absolute value of the differences to the foci must be equal to each other. So if this is d1 and this is d2, then the constraint for hyperbola is that d2 minus d1 must be a constant. Okay, so for example, d2 minus d1 must be equal to d2 minus d1 for every single other point on the hyperbola.
What?
Okay, so maybe you could also think about this point here. Okay, so that means d2 minus d1 has to be constant for every single point. The absolute value of the differences of the lengths to the foci are equal for every single point on the hyperbola. The absolute value of the difference of the distance from each point on the hyperbola to the foci are equal. It's a bit long, isn't it? So I've explained it here by saying that d2 minus d1 is a constant for every single point on the hyperbola. Is this not making sense? The blue line is the hyperbola. Every point on the hyperbola, if you draw the distances to the foci, it has to have an equal absolute value in the difference. Here are the foci, right? Look, it's the same exact concept as an ellipse, except now we're caring about the difference. Right? For an ellipse, we cared about the sum of the different distances. Now we care about the distances being the constants. That doesn't make sense. You can go look it up online later. Let's talk about horizontal and vertical hyperbolas. So what does a horizontal hyperbola look like? For a horizontal hyperbola, the line that connects the foci must be horizontal. It's what we call the axis of the hyperbola. So if these are the foci, then the hyperbola, so the two branches of the hyperbola always open towards the foci, just like a parabola. And these are going to be the vertices. So those red dot, that's the foci, that's the focus, and this is the vertex. Vertices here. Whereas for a vertical hyperbola, Evangeline, quiet please. For a vertical hyperbola, the foci now are oriented vertically. Any questions?
Is the foci like the line?
It's the point.
What's the line now?
It's the line that connects the foci. It's the axis. Let me continue. So for a hyperbola, we once again have A, B, and C, just like for an ellipse. Except the difference is that now for a hyperbola, the foci are outside the vertices. Right? For an ellipse, we had the foci in between the vertices, right? But now the vertices are in between the foci. So let's look at the case for a horizontal hyperbola. So if the vertices are here, so these are our two vertices, right? And then our two foci are going to be here, and here is our center, right? So we have a center, and then a vertex, and then a focus. So A, B, and C are defined as such. B is going to be A is going to be the distance between the center and the vertex, just like for an ellipse. And then for for the center to the focus, we're going to have C, just like for an ellipse. So the variables are named in the same way. C is the distance between the focus to the center, and A is the distance between the vertex to the center. B, on the other hand, does not correspond to any point that's on the hyperbola. And so B is going to be given to us by a simple relation, which is C squared equals A squared plus B squared.
Plus them?
Yes. So for an ellipse, it was C squared equals A squared minus B squared. Now for a hyperbola, it's C squared equals A squared plus B squared. Any questions? B is just the parameter for the hyperbola. Okay. So as you can see, a hyperbola also has two asymptotes, right? A hyperbola has two diagonal asymptotes that the graph approaches but never reaches. And we'll figure out how we can determine the equations for those asymptotes soon. Yes.
Is this horizontal or vertical?
This is horizontal. Let's talk about the equations for a horizontal and vertical hyperbola.
Yeah.
So for a horizontal hyperbola, we're going to have x minus h squared over a squared. Remember, a is the distance between the center to the vertices, minus y minus k squared over b squared, which we would find using c, right? This equals 1. So this is the exact same equation as for an ellipse, except now the plus is replaced by a minus here. And as it was for an ellipse, the right side has to be 1. Can't be anything else. So this also means that unlike for an ellipse, x and y are no longer symmetrical. So the order does matter. It does matter which one's positive and which one's negative. If it's the x that's positive, then it's horizontal. On the other hand, if it was the y that's positive, so if it was switched, such as y minus k squared over a squared minus x minus h squared over b squared, then this would be a vertical hyperbola, meaning that the axis of the hyperbola is now going to be vertical. So for the horizontal case, the axis was horizontal. So the line connecting the foci was horizontal. But for a vertical hyperbola, the line connecting the foci is going to be vertical now. So the orientation will look like that. Now, a squared and b squared are always going to correspond to the positive and negative ones respectively. So a will always be in front being added, and b will be subtracted in the back here. So unlike for an ellipse, a can be greater than b, and a can also be less than b. So there's no restriction on how large a and b can be with respect to each other. Any questions? Okay, let's talk about the equations for the asymptotes. So the asymptotes are also going to be split into the horizontal and vertical cases, and we will have two equations for those two respective cases. So for a horizontal hyperbola, the asymptotes will be given by y equals k plus or minus b over a times x minus h. So this is a linear equation, and we have two equations because we have two asymptotes, right? it's always going to go through the center of the hyperbola. So it will always go through the point h comma k, but one is going to have a positive slope and the other one is going to have a negative slope. That's why we have a plus or minus b over a. And this plus or minus b over a will correspond to the slope of the equations because it's being multiplied by the x, right? For the vertical one, it's very similar. It's just that the a and b are going to be switched. So we'll have y equals k plus or minus a over b times x minus h. Okay. So really the thing that matters most is what kind of slope you have being multiplying the x. Questions? Let me do an example, not from the classwork. This will be similar to 1e because people have trouble with that. So let's say we have okay. So let's say we have our two vertices on the hyperbola. 1, 7 and 7, 7. Okay. And let's say I also give you the asymptotes, which are y equals 2x minus 1 and y equals negative 2x plus 15. Okay. So I just chose these numbers to make it go through the center. That's about it. Okay, so how would we figure out the standard form of the equation based on these two facts? We could first figure out where the center is, right? So if I were to graph the vertices, I would have one point here, 1, 7, and the other point here at 7, 7, right? So is this a horizontal or vertical hyperbola? Thank you, it's horizontal. And the center is at 4, comma 7, right? So I have a center here at 4, 7. What is A going to be? 3, good. A is the distance between the center to the vertices, right? So A will be 3. Now, how do I find B, given the fact that I don't have C even? I'm going to have to use the slopes of the asymptotes, right? So I'm going to have to look at this 2 here and this negative 2. So because I know that this is a horizontal hyperbola, I know that the slopes of the asymptotes are going to be given by B over A, right? Because I have that equation here. I know it's horizontal, so the slope has to be B over A. So that tells me that the slope is going to be 2 for these hyperbolas, the asymptotes of the hyperbolas. Okay, so if A equals 3, then that means B will have to equal 6, right? Any questions?
Is asymptote.
A is the distance between the center to the vertices. B does not correspond to anything on the hyperbola. It's just part of the equation, right? So for the equation, we need h, k, a, and b. And so I'm going to plug this into my equation because I have h, k, a, and b. And I know it's a horizontal hyperbola, right? So I have to use the equation where x comes first. So my final form is going to be x minus 4 squared over a squared, because a always comes first in the hyperbola. So it'll be x minus 4 squared over 9, minus y minus 7 squared over 36, because that's b squared, equals 1. Yes?
How do you know the distance between the vertices to the center is A, not B? Like,
It's always a for hyperbola.
I was always A, or why is B over A too?
It's based on the slope of the asymptotes.
Okay, so.
Any questions? Let me go over one example for completing the square and you guys can do the classwork. I plugged it into the formula for the hyperbola. It's a horizontal hyperbola, so I plugged it into the horizontal formula. Let's do a completing the square question. I'll let you do your work. Suppose I have 9x squared minus y squared minus 36x minus 6y plus 18 equals 0. So this is very similar to an ellipse, right? Except the only difference is that I have a minus sign in front of the y squared. So I'm going to complete the square. I'm going to bring the x's to the front. And the y's I'll put to the back. And then the 18 I'll bring to the other side. Then I'm going to factor and then complete the square within the parentheses. So I'll factor out a 9 from the x squareds. So that's x squared minus 4x. What should I add here? 4. I'm going to add 4 divided by 2, which is 2, and then 2 squared, which is 4. But then here, it's a little tricky because I have a minus sign. I have to factor out the minus sign if I want to complete the square. So I'm going to factor the minus, and I have to make sure to factor out of -6 too. So that'll leave me with minus y squared plus 6y. It becomes plus because, it's -6 divided by -1, right? So what should I add to y squared plus 6y?
9.
9. Okay, so what should I add to the right side to compensate? -18 plus 36, right? Because I'm plus 4 times 9. And then -9, because this is a plus 9, but it's actually being subtracted, right? And so my not final, but if I simplify this, I'll get this minus y plus 3 squared equals, what is that? 9? And so my standard form will be this. Okay, and then you'll be able to find the center vertices foci equations using this information. Just make sure to pay attention whether it's a horizontal or vertical hyperbola. Otherwise, you'll get it wrong. Pay attention whether it's a horizontal or vertical hyperbola, because that will influence which equation you use, right? Yeah.
Yeah.